All right, today we're doing the section called More About Functions, and let's just jump right into exercise number 1 here, and we'll kind of figure things out as we go. It says a linear function has the table of values below related to the number of buses needed for a field trip. So we have number of students be 35, we would need one bus. And if the number of students is 70, then we need two buses, etc. Now, this is going to be a constant change or a constant rate type of problem because we really can't take 1.5 buses and the number of buses is going to go up the same as the number of students would go up the same. So it looks like one bus can carry 35 students. All right. So it says write a linear function that represents the number of buses needed. That's going to be y for x number of students. So my number of students is going to be represented by x. That's pretty obvious from the table up there. All right, so if this is a constant change, well, that tells us that our equation or our function is going to look like y equals mx plus b. All right. So what is going to be my slope? All right, and just like we've done before, we're going to use the slope equation. All right, that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, and since it's changing at the same rate up here, I can just pick any two here. I might as well take these first two to calculate my slope. So my change in y is going to be 2 minus 1, and my change in x is going to be 70 minus 35. All right, so that means my slope is going to be 1 over 35. All right, so my equation, and obviously the y-intercept is if I take 0 students, well, the number of buses I need is going to be 0. So my y-intercept in this case is going to be 0. All right. So what do we have? We're going to have y equals 1 over 35x plus 0. All right. So there it is. There's my function. All right. There's my linear function that's going to go on here. All right. So we're going to circle that or put a nice framed square around it for you. Okay, because we're going to use that later. All right. All right. Well, let's see what kind of other things they ask us to do here. Describe the limitations of x and y. This one's a little different. We haven't done this before. What kind of limitations would be related to this problem here? Well, one thing you have to notice is that you can't take 1.5 buses. Right? We can't take 2 3/4 buses. All right, so one limitation I would say would be on this number right here. These are going to have to be whole numbers. All right, so I'm going to just put the word whole numbers right here. And you can't have a negative either. You can't say that they're integers because you can't have a negative number of buses. All right, and this number up here, what about this number up here? Well, number of students. Those very well couldn't be negative, and also they couldn't be fractions either. You can't have half a student or 3/4 of a student. So I'm going to say, well, these are going to have to be whole numbers as well. All right, so, oh, that's a terrible S. Look at that one. All right, whole numbers. Okay, so those are some limitations. I mean, you could go crazy with this. You could say, well, we only have a certain number of buses available to us. We can't very well order 200 buses. And another limitation would be, how big your class size is that you're taking. So that's kind of like an open-ended thing. So, but strictly with the math, I would say, limitations is these would have to be whole numbers. To move through the problem here. So now this is kind of new. This is a little different. Is this function discrete or continuous? All right. Now, in order to determine whether something is discrete or continuous, what I want to do is I want to look at the x values up here. All right. And if these numbers that are in the x row, okay, or my input, if there's any kind of limitations on them, as far as they can only be a certain type of number, then I'm going to call that discrete. All right, and that's where I'm going to go back to this right here. You cannot say that we have 35 and a half students. Okay, it's either got to be 35 or it's got to be 36. All right, and you can't say that we have a negative number of students, right? But the more important thing is you're going to have to go from 35 to 36 students. And you're going to have to go from 70 to 71, and 71 to 72, and 72 to 73, etc. All right, you're gonna have a little jump there. All right, so this is going to be considered a discrete function. Okay, if that were not the case, if we could put any number in there as far as there's no limitations on what we could put in for x, then I would say it's continuous. Okay, so that's a little new terminology for you. All right, and that's pretty straightforward. Okay, so we'll do some others so we have examples of that as well. So let's tackle this last part down here. It says the entire 8th grade student body of 321 students is going on a field trip. So what number of buses does our function assign to 321 students? All right, well, again, let's use the function that we've already developed here. So let's go over here and plug in what number of students we want. We want 321 students, and that's your x. All right, so we're going to take 1 over 35, and we're going to plug in that 321 right in for x. And now, since we have this function, it's just a matter of bringing up our calculator and doing the math here. All right, and what that boils down to is 321 divided by 35. Now notice I get a decimal here. I get 9.2 if I round that to the nearest tenth. Okay, and what I have to do is, does that make sense in this problem that I can take 9.2 buses? All right, and it really doesn't. So can I take 9 buses and carry all those students? Well, no, this 0.2 is important. All right, so I'm going to have to round that up, and I'm going to need 10 buses in order to carry all of my students there. Okay, so we're starting to look at problems where you have to think about the context of the problem in order to answer the question. All right. Okay. What we have is we have another little part here, so I'm going to add that in. It says some 7th grade students are going on their own field trip to a different destination, but just 180 are attending. Okay, so let me get this part out of the way here, and so I have a little space to work here, and I'm going to use the same function now. All right, but I'm going to apply that to this problem here of 180 students. So, all right, so we start with this 135, 1 over 135, and now we plug in 180. All right, we plug in 180 into the number of students, and, well, the math really is the same as what we did before. Okay, but instead of 321, I have 180 divided by that 35, and what do I get? I get 5.1. Now, what we talked about before was I can't use 0.1 of a bus, right? So if that's 5.1, I'm going to need, all right, I'm going to need 6 buses to carry that amount of kids. All right, and I think we have one more part here. Let me turn this one off and this one on. And let's see, what is the number, or what number does the function assign to 50? All right. So what they're trying to say here is really the same thing. What if we have 50 students? So you know what? Let's do this. Actually, that won't work. I'm just going to put it right off to the side here, and let's take erase this right out here. Okay, and erase this part, and erase this part, and everything else is going to be the same here. I'm going to put in a 50. All right, I'm going to put in a 50 right there, and redo my math. 50 divided by 35, and that's 1.4. Okay, but of course I can't do 1.4. All right, I can't take 1.4 buses. That means I need 2 buses total. Okay, and so there you have it. All right, so that's exercise 1. We're using functions still, but we did throw some new ideas in here. This whole discrete or continuous. All right, and then we're just plugging in some numbers to the function. So let me clear the deck here, and we'll go on to example 2. All right, here's exercise 2, and it's very similar to the one we just did, but this one talks about number of tickets and total cost. So we have this table here that shows us when we buy 3 tickets, we are going to pay $27.75, and when we buy 6 tickets, we're going to pay $55.50, etc. Now, it would make sense that the cost of a ticket would be the same as you increase the number. Like each ticket is going to be the same. So this would be a constant rate type problem. All right. So we can write a linear function. Okay. And as soon as I see that linear function, again, we've said it so many times over the last month, really. We know that we can use y equals mx plus b. All right, so if we want to write the linear function, again, we've got to figure out what our slope is, right? So we're going to subtract, so it's going to be y, oh, that's really bad, y1 over, or y2 minus y1 over x2 minus x1. All right, so again, we can pick any two. Let's take the middle two here. All right, let's take these two. So the numerator is going to be my change in y. So that's going to be 83.25 minus 55.50. Okay, and the denominator is going to simply be 9 minus 6. All right, and we're going to get the old calculator out here and make sure we do this right. We're going to take 83.50. Whoops, 83.25. 25 minus the 55.50, and we get 27.25. Okay, so that's going to be 27.25 right here. And did I write that down right? 27.75. Sorry. All right, 27.75. And let's see, 9 minus 6. That's pretty easy. So we're going to take that, and let's see what we get when we divide these two. And if it comes out, oh, there we go, 925. All right, so I'm going to use my slope as 925. So now I can go ahead and I can write my linear function. Y equals 925x. And again, think about if you buy 0 tickets, well, what's going to be your cost? It's going to be $0. So your y-intercept, again in this case, is just 0. So here is your function. All right, there's the equation that's going to say derive this situation here. So as we did in the previous one, is the function discrete or continuous? Well, again, go to the x values up here, and can you buy, is there any limitations here? Can you buy 3.5 tickets? Well, no, you can't buy 3.5 tickets. All right, can you buy 9.25 tickets? Well, no, these have to be simply whole numbers in here. All right, so that's going to tell me that that is a discrete function right there. Okay. And let's see, what's the last part? What number does the function assign to 4? Well, now that we have this function, all right, now that we have this guy right here, we can just plug in a 4 to the number of tickets. They're asking, what if I buy 4 tickets? So here we go, y equals 9.25, and I'm going to plug in a 4. And good, that's nice because there's no algebra to do. You're just going to multiply 9.25 times 4. And what do we get? 37. All right, so I'm going to just plug in a 37 right here, and there's my answer. So $37 is what we're looking for 4 tickets. Okay. All right, that was pretty easy. Let's put this one away and take a look at this one. All right, a function produces the following table of values. Now this is a little different, right? We don't have numbers in here. We have words. Okay, but that's okay. We can do this. If we input the word banana, whatever function, whatever it is, whatever the rule is, it's going to output yellow. All right, and if we input cherry, it's going to output red. So we put in orange, and we get out orange. We put in tangerine, we get out orange. We put in strawberry, we get out red. All right, so can this function be described by a rule using numbers? Well, no, not really. All right, unless we assigned a number to each one of these and to each one of these, and then it really wouldn't make mathematical sense. So it still is a function, okay, because each one of these inputs only assigns to one output, okay, so it still is a function, but no, you can't use, we're going to say no, because it just wouldn't, there is no mathematical rule here. Okay, so I'm going to put no mathematical rule that describes this situation here. Describe the assignment of the function. Well, if you think about it, what are we doing here? We're inputting a fruit, and we're outputting the color of that fruit. Okay, if you didn't see that before. And state an input and the assignment the function would give to its output. Well, this is pretty open-ended here. All right, and I'm going to leave that to you guys. Come up with some kind of fruit, right? Some kind of fruit that isn't listed here, and then come up with the output that it would assign to that fruit. Okay, we'll see what you guys come up with. All right, so there you have it. That's the video for tonight. Hope it was a good one for you, and I hope you enjoy the rest of your night, and thanks for watching.